Welcome to the lecture series of probability and random processes and applied statistics. Today we are going to discuss exponential distribution. The definition is a continuous random variable x is said to follow exponential distribution with parameter lambda. Then the PDF is given by f of x is equal to lambda e power minus lambda x such that x greater than 0, 0 otherwise. So this is the definition for exponential distribution. This is also comes under the continuous random variable. So the PDF is given by f of x. It's nothing but lambda e power minus lambda x, x greater than 0. So this is the definition for exponential distribution. As usual, the first question is find the MGF of exponential distribution. Using it, find the mean and variance. Look at the question. Find the MGF of exponential distribution and using it, find mean and variance. So as usual, what is our mx of t? The solution is, we know that mx of t is equal to, mx of t is nothing but expectation of e power tx. Okay, here it is a continuous random variable, so we can go with integration. So which is equal to integral minus infinity to plus infinity, whatever it is inside the expectation, that one. So e power tx into f of x dx. Okay, here our f of x is a exponential distribution with x greater than 0. X greater than 0 means the limit is 0 to infinity. So in the next step, this can be written as integral 0 to infinity e power tx into f of x. F of x is nothing but lambda e power minus lambda x, okay, into dx. Here integration with respect to x, so we can take the lambda outside. So this can be written as lambda into integral 0 to infinity e power tx e power minus lambda x into dx. So in both the term we have e power. So put together we can write this as integral 0 to infinity e power t minus lambda into x dx. Okay. So that is equal to lambda into integral 0 to infinity. You can take the minus outside. So this can be written as e power minus lambda minus t into x dx. Now we are going to integrate this with respect to x. E power minus x integration is e power minus x by minus 1. So by the same manner, this can be written as lambda into e power minus of lambda minus t into x divided by minus of lambda minus t with the limit 0 to infinity. Okay, here the limit 0 to infinity. So before applying the limit, we can take the minus lambda minus t outside. So this can be written as lambda minus lambda by lambda minus t into upper limit is infinity and the lower limit is 0. So e power minus infinity minus e power 0. Okay, e power minus infinity is 0 and e power 0 is 1. So this can be written as minus lambda by lambda minus t into 0 minus 1. Okay. So minus into minus plus, so lambda by lambda minus t. This is our mx of t. So mx of t equal to lambda by lambda minus t, and this can be written as lambda by lambda into 1 minus t by lambda. So we can cancel these two. Therefore our mx of t for exponential distribution is 1 by 1 minus t by lambda, that is equal to 1 minus t by lambda whole power minus 1. Okay. Now this is of the form 1 minus x whole power minus 1. In the binomial expansion, this can be written as 1 plus x square plus etc. So in the place of x, here we are having t by lambda. So mx of t, therefore our mx of t is equal to 1 minus t by lambda whole power minus 1. Okay, and this can be written as 1 plus t by lambda plus t by lambda the whole square plus etc. This is our mx of t, and using this mx of t, we are going to find the mean and variance. For that, we are going to differentiate this mx of t with respect to t and then put t equals 0 so that we can get mean. For the variance, we have to go for the second derivative. So to find the mean, mx dash of t equal to, here the power is minus 1. So minus 1 into 1 minus t by lambda whole power minus 1, that is minus 2. Differentiation with respect to t. So into what? Into minus 1 by lambda. Okay. So minus into minus plus. This can be written as 1 by lambda into 1 minus t by lambda whole power minus 2. So in this one, mx dash of put t equal to 0 in mx dash of t. So what will happen? Mx dash of 0 equal to 1 by lambda into 1 minus 0 whole power minus 2, that is equal to 1 by lambda. So our mean is nothing but mx dash of 0 equal to 1 by lambda. Okay, this is our mean, that is mean is equal to 1 by lambda. Okay, this is one result. Next we are going to find the variance. To find the variance, we are going for the second derivative, that is mx double dash of t is equal to. Okay, already we got the answer for mx dash of t. This one we are going to differentiate again with respect to t. So 1 by lambda is a constant, you can write as it is, and minus 2 will come in front. So minus 2 into 1 minus t by lambda whole power minus 3. Again differentiation of this term is minus 1 by lambda. Okay, so minus into minus plus, this can be written as 2 by lambda square into 1 minus t by lambda whole power minus 3. Put t equal to 0, what will happen? Mx double dash of 0 is equal to 2 by lambda square into 1. Okay, so that is equal to 2 by lambda square. We know that the variance result is nothing but, therefore our variance of x is equal to, actually mx dash of 0, that is our mean is nothing but mu 1 dash, and this is nothing but mx double dash is nothing but mu 2 dash. So variance result is mu 2 dash minus mu 1 dash the whole square, that is mx double dash of 0 minus mx dash of 0 the whole square. So this is nothing but mu 2 dash and this is nothing but mu 1 dash. So substituting that value we can get the variance. So here the mu 2 dash is nothing but what? 2 by lambda square. So 2 by lambda square minus mu 1 dash the whole square. What is our mu 1 dash? Mu 1 dash is nothing but 1 by lambda. So 1 by lambda square, that is 2 by lambda square minus 1 by lambda square. 2 minus 1 is what? 1. So 1 by lambda square. Therefore our variance is nothing but 1 by lambda square for exponential distribution. So this is the way we have to do problem under distributions. This is the last distribution under the second unit. So exponential distribution definition, finding MGF for the exponential distribution, the result is lambda by lambda minus t. So differentiating that we can get the mx dash of t. Put t equals 0 so that we can get the mean. Mean is nothing but mu 1 dash, and again going for the second derivative, put t equals 0, that is nothing but mu 2 dash. We know the result for variance. Variance of x is nothing but mu 2 dash minus mu 1 dash the whole square. So our second derivative is mu 2 dash, first derivative is mu 1 dash. Substituting that we can get the value for variance. So up to this the distribution properties, all that is over. Next we are going for the bivariate distributions. Okay, thank you for watching.